Here is an important video in which we will learn how do we find maximum and minimum points on the graph of a trigonometric function. Very important strategies have been discussed and I hope that will help you to solve similar questions. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up a very interesting question to find extremas in a trigonometric function. Extrema really means both maximum and minimum from the graph of a trigonometric function. So you need to find the coordinate points x, y and also identify which is a maximum and which is a minimum. Clear? So the question for us is find maximum and minimum points on the graph of f of x equals to cos 2x plus cos square x, where x is between 0 to 2 pi. You can always pause the video, answer the question, and then look into my suggestions. In case you want to learn from me, you can send an email on the address given.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now let's see. How do we go about? I have seen most of the students. They will straight away find the derivative of this function, right? Now, no harm in doing so. However, you notice here that we have cos 2x and cos square x both in the given equation. So in such cases, the approach should be write the function in one argument, either 2x or x square, and then find the derivative. That is to say, do not rush for the derivative, right? Okay, now how do we do that? You know what cos 2x is, right? Cos 2x can be written as 2 cos square x minus 1 using the double angle formula. Now from here, you can write cos square x as in terms of cos 2x. So let's rewrite this. So we get 1 plus cos 2x equals to cos square x. It is times 2. Let's go one more step. So cos square x can be written as half of 1 plus cos 2x. Clear? So you see, cos square x is actually half of 1 plus cos 2x. So what we should do here is, instead of finding derivative straight away, we should simplify the expression. So we'll do that. So you write f of x is equals to cos 2x plus, instead of cos square x, I am writing half of 1 plus cos 2x. So that gives you cos 2x plus half cos 2x. Is this step clear to you? If you don't do this step, you might finish up doing the question, but it will be very, very lengthy. So combining, we get half plus cos 2x plus half cos 2x, right? Which is half plus 1 plus half is 3 by 2 cos 2x. So you see the first step. First step should be simplify, right? Now, once you have simplified, then you go for derivatives. So now let's look into the simplified version. We already wrote this function f of x as equal to half plus 3 by 2, 1.5 cos 2x. See, it is much easier to differentiate this function, right? So the derivative of this is, derivative of half is 0, and then we have 3 by 2 times cos 2x derivative is minus sin 2x, and then derivative of 2x is 2, which means that I could cancel these two, and therefore I can now write this as minus of 3 sin 2x. Now the question is, find maximum and minimum points on the graph. So first derivative will actually give you critical numbers, right? We should also find the second derivative. And we are going to identify whether the critical numbers are maximum or minimum using second derivative. So that is going to be our approach. Okay. So we have the first derivative, which is minus 3 sin 2x. Let's also find the second derivative. Second derivative will be minus 3, and sin 2x derivative will be cos 2x, and 2x derivative is 2, and therefore we can write this as minus 6 cos 2x. So we got both the derivatives. Now, one more thing before going further and rushing into the solution, let's also look into the domain of the question. Since our argument is 2x, right? Theta is 2x, not x. So, if x is between 0 and 2 pi, then 2x should be between 0 and 4 pi, right? So the domain for sin 2x or cos 2x. Do you see that? This is also important to identify. So now on this page, we have the first derivative, second derivative, domain, everything. So we can actually pause the video and find both maximum minimum points, right? So now let's analyze the first derivative now. So if analyze the first derivative, we know that the first derivative for us is equal to, let's rewrite, minus 3 sin 2x. So we have to find the critical numbers. These are smooth curves, so we are looking for the points, the stationary points where the derivative is 0. So that means 0 equals to minus 3 sin 2x. And where is 2x? The domain of 2x is from 0 to 4 pi. So any angle theta, sine theta, when is it equal to 0? Well, let's look into the sine graph for easy solution. So let's say this is a sine theta graph, right? So these are the zeros, correct? So between 0 to 4 pi, the zeros will be at 0. Then we have at pi, 2 pi, 3 pi, and 4 pi, correct? So we have our critical numbers for this particular function at 2x equals to 0, pi, 2 pi, 3 pi. So x will be equal to 0, pi by 2, dividing by 2, right? Pi, 3 pi by 2. So there are 5 critical numbers in this particular case. You get the idea. So there are 5 critical numbers which we need to analyze. Now, some of them could be alternately, they will be maximum minimum. So we need to figure out maximum minimum. So out of this, now you have an option. The option is do the sign chart. Now, how to identify that these are maximum or minimum? This is the major question, right? So we have two approaches. One is sign chart. You can see how the maximum minimum changes, right? And the second option is we could use second derivative, which is concavity. Since we have 5 points to work with, sign chart is more complicated, right? So better method will be go for the second derivative. You get the idea? So we'll go for second derivative and we will see for 0, pi by 2, pi 3 pi by 2, what is the case, right? So let's try to analyze the second derivative. Okay. So rewrite first and the second derivative. So the first derivative was what? Again, minus 3 sine 2x, and that is minus 6 cos 2x. Minus 3 sine 2x. And the second derivative is minus 6 cos 2x. Clear? And our critical numbers or critical points are, you can also call these points as stationary in this particular case, since these are the turning points. Let me write down both the things here. Some students will use stationary points. Turning points, okay. So from the first derivative test, we just figured out that the stationary points are at x equals to 0, pi by 2, pi, and 3 pi by 2. Now for each point, we have to see whether the value is maximum or minimum. Concavity is up or down. So let's put them one by one in the second derivative. So that is what we mean, check concavity. Beginning with the very first one, which is 0. So second derivative at 0 will be what? Minus 6 cos of 0, right? 2 times 0 is 0. And you know cos of 0 is 1, and therefore minus 6 is the value. If minus 6 is the value, then the graph is concave down and we have maximum, correct? So at 0, we have a maximum. Clear? So we can find out that maximum at 0. Now let's see the next point, which is pi by 2. So second derivative at pi by 2 is what? Minus 6 cos of 2 times pi by 2. Now 2 times pi by 2 is cos of pi. That 2 and 2 cancel, right? Pi is minus 1, and therefore you'll get this value as plus 6. Plus 6 means the graph will be concave up. And concave up means you have a minimum. Is that clear? Do you see how easy it is? So we got minimum at pi by 2. So continue. Plug in pi now. Minus 6 cos of 2 pi. Cos of 2 pi is 1, so we get minus 6 again. And so we have a maximum, correct? And the last point for us is 3 pi by 2. Cos of 2 times 3 pi by 2, which really means 3 pi. So that means it is negative, and so we get a positive 6 here. And the graph is concave up. Clearly, that is minimum. So, do you see what? We got our minimum and maximum points for the given function. And the function was what? The function is just given here, but we know what function is. This function f of x, which is given to us as cos of 2x plus cos square x. We wrote this function as, simplified it, half plus 3 by 2 cos 2x, right? Cos of 2x. So that was the function. Now in this function, you can put 0, pi by 2 and find maximum minimum value, right? So the values are, substitute 0 here. So when you substitute 0, you get half plus 3 by 2 of cos 0. And that gives you the maximum value of half plus 3 by 2. And that is 2, correct? 4 by 2. So that is the maximum value. Similarly, substitute the value pi by 2. And when you substitute pi by 2, you get half plus 3 by 2 cos, pi by 2 is cos pi, right? Which is negative 1. So you get this as minus 3 by 2. And that is, you get minus 1. Do you see that? So your maximum is 2 and minimum is minus 1. You get the idea. So let's review what we have learned just now. Here's a part of the graph, right? So we have shown a part of this graph of the function f of x. You can clearly see that the maximum value is 2 and the minimum value is minus 1. Do you see that? So it is very important to find the maximum minimum value also. So from our result, once again, we first identified that this should be written in 2x form. So we got this as half plus 3 by 2 cos 2x. And for this particular function, we have maximum values at 0, and at 0 the value is 2. And then we have a minimum value at pi by 2, which is minus 1. And then at pi, we had the maximum value again of 2. And then at the next point was, actually it was pi by 2 and pi, right? 3 pi by 2. So there were 4 critical points. 3 pi by 2. Rather, there should have been 5. Let me just check. So 1, 2, 3, 4. 4 pi was also a point which we did not write here. Half of 4 pi will be 2 pi, right? So 4 pi will also be a point, right? Because there are 5 critical points you can see, right? Yes. So we'll also find at pi, right? 2 pi. So at 2 pi, the point is going to be cos of pi will be -1. So we get -6 cos of pi, which is equal to 4. Cos of 4 pi. So we'll put 2 pi there, so 2 times 2, which is going to be positive, and so the answer will be negative. Right, so forgot to add this. Please add this. Clear. So in this case, we have the next value, which will be at 3 pi by 2, which is -1. And then 2 pi. And then a maximum of 2 at 2 pi, right? So extend this graph, and those are the points which you get. Perfect? So we get our final answer that there are 3 maximums and 2 minimums in this particular case. Perfect? So the graph will be, you can extend this graph. Let me make a smaller one. The maximum for this will be at 2. The minimum is going to be at -1. And cos 2x basically will mean 2 waves in 2 pi. So let's make these 2 waves in 2 pi. Dividing them into quarters, just to simplify. It's a small space. We'll sketch the cos axis is at half, right? So maximum axis, minimum axis. Maximum axis, minimum axis. So that's the second wave, right? So you can see that there are 3 maximum and 2 minimum as specified here. Perfect. So that is how you are going to answer this particular question. So the key areas are that when you look into this, do not straight away go for the derivatives. First, simplify the expression. Write it as 2x form, and then find the first derivative, also the second derivative, all the 5 critical points which you get, find the y values, and then write down both maximum and minimum points for the function. And if necessary, sketch the graph, right? So I hope with this, the concept is absolutely clear. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.